Welcome guys. In this particular video, we're going to go over problem set 6, which is in Python. And I am just going to walk you through the solutions and how I approach the problem. A disclaimer that this video is for educational purposes only. Cheating or any other form of cheating is highly discouraged. So I just want you guys to know that this is just for education purposes and sort of think about how to approach the problem, etc. So let's get started with that disclaimer. Okay, so the idea is that in problem problem set 6, we want to do some Python exercises with some of the ones we did in the previous week. So I'm going to go ahead and create problem set 6 in a folder called problem set 6. So I'm going to make directory problem set 6, and I'm going to go into problem set 6 as well. Okay, so while I'm at it, why not make directory Mario less, make directory Mario more, as well as cache, credit, readability, and DNA. And am I missing something? I think that's pretty much it. So that's all the main function. So let's go inside Mario, or actually hello is one more thing that we have to write, I believe. So let's go ahead and do it. So first one is hello in Python. So let's so let's push the hello, and we can pop out of it when necessary. Okay, so now what I'm going to do is I'm going to touch hello.py, create a Python file, and I'm going to actually open it here. So hello. Okay. Okay, so what we want to do, the same exact thing as we did in this .c file, but with Python. Okay, so let's go ahead and figure out how to get input. Luckily, the notes has all the information, excuse me, of how to get the input here. So if I do get string from CS50, import get string. So we just import that and we import this. So this entire code is actually present. You can just copy paste. So what's your name, and hello followed by the name, right? So we just change it to this guy right here. What is your name? And then that's pretty much it. Okay, so let's go ahead and do that. Yeah, let's go ahead and do that. So that's all there is to it. Now let's go back here and we'll say Python hello.py. What's your name? And you just type in Emma. Hello space Emma. Is that correct? Okay, that works. Let's submit it. Okay. So pretty straightforward. Nothing much. It's just sort of to get a hang of Python, I guess. Just import the getString library from CS50 and print out the name. Okay. Yes, I do want to do that. Okay, so while we're at it, why not go ahead and do the next one? Okay, let's open this. Waiting on results. Okay, come on. Okay, 3 out of 3. Okay, good. Okay, so the next one would be I believe it's Mario. So let's go back and check. Mario less. Okay. So a disclaimer here, if you haven't watched my PSET1, the problem set 1, please go ahead and do that. I'm not going to go over the main logic of how to code this because most of the logic is already covered in PSET1. This particular prompt is only going to focus on translating the C code into Python. So it's just going to be translation of code from different languages rather than actually explain the logic. Okay, so if you want to know more about the logic, please visit problem set 1 and my explanation for that. Okay, okay, so let's go to pop d, push d, Mario less, touch Mario.py. Okay, so we want to do so let me actually open up my problem set 1 for Mario less here. And as you can see, .mario.c, I get int, right? So, and I have to validate that the height is a valid one. Okay, so how can I do the same thing? So from CS50 import, so instead of this, I do, let me go here. So get string, okay, and then in Python, what I have to do is there's no concept of do while. So what I do is I just get a particular height, right? So I just say height equals get integer, right? I wonder what CS50 calls it. I think it's get int here. So I get int, okay? And yeah, so let me just go ahead and call get int, and the Mario will pass in a height, right? So this part stays the same. Actually, nothing changes from PSET1. It's just different language, okay? So I get the height like so, and after the statement, if height is between 1 and 8, I have to break out of the loop, else I have to keep on validating the user, okay? So now what I can do is, now height is valid, now height is a valid integer. Okay, now what I can do is I can have that logic to print. So if you remember, you have row from 1 to the height. So let me just go ahead and do that. So we have to repeat for each row, right? So let me close this, Mario.py. So for row in range 1 to height plus 1, right? We want to repeat this operation. And what do we want to do? Inside here, we printed the number of spaces. We printed some amount of hashtags. So basically, we have to print some amount of spaces and some amount of hashtags, okay? Specifically, we have to print height minus row amount of spaces and height and row number of hashtags. Luckily, in Python, it's so simple. If you want to print a character n number of times, you can just use the multiplication operator, okay? So what I'm going to do here is I'm going to first print the spaces times height minus row. This is going to print the space height minus row times, okay? Next, what I'm going to do, I'm going to print the hashtag row number of times, and I am going to print a new line, but I don't have to print a new line because Python automatically adds a new line. So let me go ahead and do this. What is it saying? Undefined get int. Okay, yeah, like so. Okay, so that should pretty much be it. So what I'm essentially doing is I'm replacing this inner logic and looping over a given range and printing a single character. You can do that easily in Python using this multiplication operator, which I've taken advantage of. Okay, so now let's compile this again and try running it. Okay, so now Python Mario.py, and let's put in height of 4. Okay, unsupport operations minus unstring. Okay, yeah, so this probably needs some parentheses here, right? So this should be a parentheses because of precedence of operators. Okay, let me go ahead and execute that. Okay, cool. So this works. So let's try submitting it now. Okay, so as you can see in Python, it's ridiculously easy because we just have to input that. Okay, clear it, submit Mario less. Okay, okay, cool. So while that's going on, let's open the next one. And I guess I can open a new terminal and try working on that, or I'll just create one here, I guess. New file and Mario.py, and I can copy all my contents from here. Okay, so I'm going to close this, open this. We're waiting on results. Okay, come on. As you can notice, Python is slower, but we got 9 out of 9, which is good. Okay, so next let's move on to Mario more. Okay, so what I'm going to do here is I am going to open this Mario more and copy paste from Mario less. Okay, the only modifications I have to make here is in Mario more, I have to also print the right aligned, left aligned pyramid as well. Okay, so if I open Mario more, I have to print 2 spaces followed by the left aligned pyramid, which consists of row number of hashtags. Okay, so that's also really straightforward, just one line change. What I do is hashtag times row times spaces times 2 plus, so 2 spaces followed by row number of hashtags, hashtag times row. And that's pretty much it. I think I don't need to even probably compile it, but let me go ahead and do that nevertheless. Push D Mario more, and then Python Mario, and then let's type in, say, 4. Okay, it works. Okay, so let me go ahead and submit it now. Like I mentioned, it's a very minor, very minor change from Mario less. So, and if you're confused about the logic, please refer to problem set 1. I'm not going to explain the logic. I'm going to explain how to translate the C code to Python code and how to make it really Pythonic in nature. Okay, so that's Mario. The next problem we'll be solving after Mario, let me close this, is cache. Okay, so as you can recall, in cash, we have to report the total number of coins that is used. So let's open this, and while that's going on, let me move to cache. So push the cache. And in cache, if I open the C program, what you'll observe is I have to first get float. Okay, so we have to do the same exact idea as Mario.py here. So let me copy this, in fact. Okay, we got 9 out of 9 for Mario more, so that's good. Now let's move on to cache.py. ls, okay, touch cache.py. Okay, clear. Okay, so now we're at cache. Let me go here, copy paste this. Instead of get int, I should do get float as per my cache dollars. Okay, so I do the same exact thing, right? Nothing changes there. And I say dollars equals that. And I do while dollars is less than 0. So if it's greater than or equal to 0, I break. Okay, so if the dollars is greater than or equal to 0, I break. Okay, so after this, I am in good shape. All I have to do is say cents equals dollars times 100 or something like that. Yeah, dollars times 100. So now it's cents is actually integer here. So what I want to do is I'll probably round it up here. If I do something like that, I don't know if that's gonna round it up. I think it should. Let me check here. Okay. I do this. Okay, so now I have cents as an integer. So after this point, what I have to do is execute this algorithm here, where I just divide and find the total maximum quarters first, total maximum dimes first, total maximum nickels later, and then total number of pennies. Okay, so I do this operation here, and I have to do it for each coin. Okay, so that's pretty much it. So let me just go ahead and do that. So the beauty in Python is iterating is a lot more powerful. So you can actually create a list on the spot of these coins and iterate and divide by them. Okay, so I'm going to replace all these lines of code by just having a list of integer in which there's 25, 10, 5, 1. And as you can see, I'm applying the same set of operations, division and mod. So I can simplify this code and make it really Pythonic in nature by doing something like this. For coins in 25, 10, 5, 1, what I'm going to do is I have some total coins, which is set to 0. And what I have to do here is I say total plus equals cents divided by my current coin. Cents divided by my current coin. Okay, my current coin will iterate. So first iteration, it'll be 25. Second iteration will be 10. Third iteration will be 5, and fourth iteration will be 1. Okay, and the remaining what's it called? The remaining cents will be modded, right? So I just say cents equals or cents mod equals coin, and then I can just print the change ode using f strings here. And what do I have to print? I just have to print the coins actually. So total, I guess. So print total, I guess. So let's quickly try this out. Python cache change ode 0.41. Oh, okay, that's clearly wrong. We did some mistake here. Okay, let's check where we made a mistake here. So this is fine. This is fine. Oh yeah, this is a float, I guess. So we need to actually divide this by actually this is integer division. So if you do double dash, I think it's an integer division. And what else here? What else? Yeah, let's check again. 0.41. Okay, now it works. Okay, so the error is that in Python, just normal division actually gives you a float, and 2 dashes gives you actual integer division. Okay, so now this seems right. So let's try submitting it. Okay, blah blah blah, submit. Okay, so after this, the next okay, so after this, the next problem to be explored is actually credit.py. So let me just do that. And in credit.py, what we have to do is we have to validate a credit card, right? And clear this. Okay. Oh, actually, I lost this thing, so let me just go up. 10 out of 10. Okay, so that is also done. Okay, in credit we have to validate it. So in here actually I'm going to use string to validate it. So let me just open my credit dot from PSET1, and I'm going to use get string. Okay, so what I'm going to do here is from CS50 import get string, from CS50 import get string, and what I'm going to do here is credit equals this number, right? So equals this number, but I have to validate it, right? So what I'll do is I'm gonna keep doing this while it's a valid one, I guess, right? So let me go back here, I guess. Go to credit here. I take the number here and yeah, so I take the number here and validate that it's a valid credit card number. So yeah, so let me go ahead and do that. So I don't know if I have to validate it doesn't actually explicitly say to validate, does it? Valid. What if you put invalid input? Oh, okay. You don't put dashes, I guess. So that makes it even easier, actually. Yeah, so I'm going to take it as a string, and I am going to apply my Lund's algorithm to it, okay? And you can use get string. Okay, so let's go ahead and do that. Okay, so I got my credit card number, and I'm going to maybe write a function, right? Should I write a function? I don't know. What we're going to do is we're going to run the Lund's algorithm, okay? So let's not write a function, I guess. We'll just make it really simple and easy to understand. So if you recall the Lund's algorithm, start from the last digit, takes every other digit, multiplies it by 2, and every digit from the last is summed up. So let's do that first, okay? So let's go ahead and create copy credit equals credit, and actually not get long, let's do get string here. Okay, so what we're going to do is we are going to actually let's do this. We're going to take credit, convert it to a list, and reverse it on the spot like so. After we reverse it on the spot like that, I think we can just do this. So now we have the reverse number. So we have to go through every other digit and multiply it by 2, right? So every other sum is equal to okay, one more thing I have to mention. I'm going to use in this tutorial a concept called list comprehension. Okay, list comprehension. This is not really a beginner friendly per se. This is like sort of intermediate Python. So you can look this up. So the idea in list comprehension is instead of writing explicit for loop and putting some code like so, you would condense everything into a list, and you could put the list expression inside the list itself. You can put an expression like so. Okay, so that's what I'm going to do here. I'm going to use this list comprehension, dictionary comprehension, etc. So please read up on list comprehension, dictionary comprehension online. It makes your code more Pythonic. Okay, so I'm going to calculate every other sum starting from the last one. Okay, so how am I going to do that? Okay, so what I'm going to do is I'm going to do for I in range 1 through or actually I can just use a slice operator. Okay, so what I'm going to do is do something like this. Copy credit. I'm going to start from 1, okay, and I'm going to go until the end of the array with increments of 2. I can do like so, okay, and the first sum, right? The other sum is just regular sum of starting from copy credit from 0th index and skipping by 2. Okay, so if I just print this out, every other sum, right, and then print first sum, you can see those are lists, I believe, because you're taking slices. Okay, so let's go ahead and actually print that. Okay, so Python credit.py, and we are going to supply this guy right here. There's a convenient one which has 20 actually. Let's open problem set 1. and forget the one that has 20 actually credit. Okay, this guy right here. Okay. Okay, so this is, so you're going through every other, see how you're going through, this goes through every other digit, right? And so the last one will be 4. Okay, and starting from here you go through every other digit. Okay, so now what I want to do is I want to take each digit multiplied by 2 for the credit part. Okay, so I want to take this and I want to take every digit and multiply it by 2. So how do I do that? I do 4x in this guy right here, and I take x times 2 for each one. Make sure to convert this into an integer, multiply it by 2, I can do the same for this guy right here. So int x for x in this guy. Okay, if I do this and now print it, let's see what happens. Okay, so I do this, I supply this guy. So now, as you can see, these are the numbers which appear here, I believe. Here, this guy. So 20001208. Okay, that's that. 1208, and then 40030 is the one that appears here, I guess. 400030. Okay, so notice how we have extremely condensed our logic here. Let's go ahead one step further and do something like 2, and what we're going to do is we're going to divide by 10 plus int x mod 10 for 2 digits. So this also works for 1 digit. So say assuming you have something like 5, right? Then 5 divided by 10 will be 0, not 5, but like say you have something like 4, right? 4 divided by 10 is 0, and then like integer division is 0, and then 4 divided by 10, 4 mod 10 is 4. Okay, if you're confused about this logic, please go back to credit in the first problem set, and let's check it out right now. Let's see what we get. So 12 should be condensed to 3 here. So when I print this out again, if I repeat this operation, it should be let's see, set is that right? 200, no, that's not right. So let's see where we made the mistake here. Int x times 2. Oh, okay, yeah, this should be again 2. Okay, so there might be a little more parentheses going on here, but apologies. Okay, so that's let's check it right now. Okay, perfect. Look at how symmetric that is and how exactly that matches here. And all it took is a few lines of code. Okay, so now let's just sum it up, and yeah, so we can condense this even further and just say sum of this guy right here, and then the sum of this guy right here, and yeah, so if we do that, then print every other sum plus first sum. Okay, in Python you can just chain everything together and make it just one line, which would be super awesome. So let me go ahead and do that right now. 20, perfect. Okay, that's the Lund's algorithm's sum, checksum for this example right there. Boom, right? So pretty slick, right? So pretty slick. So let me go back here and I'll say if so you know what, I'll just condense everything and write it in one line. So I'll just say this plus this. Okay, so what I'm gonna do is I'm gonna do it like this: total sum equals this guy. If total sum mod 10 is equal to 0, then it could be a valid card, right? So I'm going to write some code here, else I am going to print it's invalid. Okay, invalid. Okay, so what is the code I'm going to write here? So now I have to validate the length and the initial starting digits and so on. So let me consult my previous C program for that one. Okay, so what I do is here I say American Express start with these, but like blah blah blah, right? And the total length should be blah blah blah, right? So total length should be 15. Okay, so if length of credit is equal to 15, and what do you call it? Let's see. Amex start is the first two digits, right? So credit at first two. How do you get the first two? You take slice from 0 to 2, so you get the first two, is equal to 34, or let me do like so, in 34 37. Okay, then it's a Amex card, I believe. Amex. Okay, print Amex. Perfect. Else if the length of the credit is equal to 16 and it's in between these ranges. Okay, so, and credit from 0 to 2 is in between, int of credit is in between these ranges, which is 51 through 55. So in Python, you can just write it like this, super slick and super awesome, right? Then it's a MasterCard, else if the length of credit is equal to 16 or 13, length of credit in 13, 16, and Visa start equals 4 if it starts with 4, I believe, right? So if it starts with 4, 4. Okay, so credit at 0 is equal to 4. Then I print Visa. Then else it's an error, so I print invalid. Okay, super awesome. Okay, so let me go ahead and test it. I wish there was a checker. Is there a checker for this one, for Python program? I don't know. Let me just test it, I guess. Python credit, and then I supply not this guy, but these ones, I guess. Amex, that's right. Let me just test MasterCard here. MasterCard works perfectly, and then Visa here. Okay, perfect. Let's try submitting it. Okay. I didn't test the invalid one, but I think I'm pretty confident. Let's check. Okay. Yeah. Okay. Yep. Okay. So awesome. It just took us probably 10 lines of code. Wow, that's amazing compared to like a lot of lines. Okay. So now the last one is actually finding readability. Actually, not the last one. Sorry. There's readability also. Yes, readability. So yeah, so let me go ahead and see what we got here. 8 out of 8. Okay, so next one is readability. So pop D, and then push D readability. Push D readability. And now what we're gonna do is we're gonna touch readability.py. Okay. Yeah, let's just open readability, and then we have to do the same exact get string here, but we have to take in the readability, and then same exact idea, readability here. Okay, so this is what I'm going to do. I'm going to take in a text, so I'm just going to replace this guy with text here. Okay, what I'm going to do now is yeah, so I'm going to this will be the text. Okay, and what I want to do is I want to compute the readability using the using this formula right here, which would be so I'm going to store this somewhere, the result, and yeah, if result is less than 1 or something, I forget what the conditions was. If is actually, let me just take a look at my C program here. Where's my C program for readability? Oh, it's the problem set 2 actually. Yeah. Okay. So if index is less than 1, I print before grade 1. Print before grade 1. Blah blah blah. Else if result is greater than or equal to 16, I print grade 16 plus, right? And else I'm going to use a f string here to print, interpolate and print grade followed by the index by the result, I guess. Okay. And I should be good after that. So let me go ahead at 0.5 and cast it to an int. so to just make it an integer. Okay, I don't remember the round function for Python. Maybe round exists, but I don't know if I have to import something or not. Let me just quickly check what is, okay, yeah. Okay, so this is fine. Okay, so now we have to define L and S, which is the total number of words in L. It's the ratio, I believe. So I have to go back and check here. Readability, L is letters times 100 divided by words and so forth. So, and then S is sentences divided times 100 divided by words. Yeah, and then I have to do let me see here. So yeah, so now I have to compute the total number of letters, sentences, right? So to do that, I just have the same exact idea as here. So I have int letters, sentences, words set to 0. There's no int. I just do like so. I think you can do that. Okay, so now what we can do is we iterate over each character. So we say for char in text, if char is alpha, right, I just increment letters plus equals 1. Else if, or I'll just say if char is a space, then I increment the words plus equals 1. Else if char is in the question, if it char is equal to question mark, dot, or exclamation mark, sentences plus equals 1. And recall how we said if it's hello world, it will only be one word because there's only one space, but we actually want to increment it here, right? I mean, basically saying that the test cases aren't comprehensive, so this should be good enough in most of the sentences. So after we do this, then we have the total letters and words, and then we just plug into the formula here, and out we get the result. And let me see if I did anything else here. That's pretty much it. Yeah. So notice how compact it is. Let's quickly test it. So let's check readability. Python readability. The text is congratulations, today is our birthday, blah, blah, blah. Oops. So let's, okay, great. It works. Okay. So let me go ahead and submit it while I'm at it, and probably take a break after this. Okay, so while, yeah, so it's uploading. So while we're at that, let's open the next one, which is the final one, which is DNA. Okay, so for DNA, push the DNA, yeah. So let's, let me not clear it, actually, let me open this. I don't know if I should take a break here. Okay, let me see if I can take a break here, and I'll be right back with DNA. Okay, so with DNA, the idea is that you are given some large database of DNA and you want to find the consecutive strands of a DNA, the maximum amount of consecutive strands to a DNA, and you want to map that to an individual person, okay? So I highly recommend you to read the prompt as well as watch the walkthrough for this. So let's quickly go ahead and download everything that we need, okay? So we have, we need to download this. So let's go ahead and do that. And as you can see in the previous problem, we got 10 out of 10, so we're good there. Yeah, so let me go ahead and download this and unzip dna.zip and remove recursive force dna.zip. Okay, I think that's all we need. We can close readability. Yeah, so let's go ahead and do that, and lsdna, or sorry, change directory in DNA. Okay, so cool. So now we're in DNA. We have databases and sequences. We just have to write a Python script, which correspondingly opens the file and does some computations with it, right? So we have to create, okay, in a file called blah, blah, blah. Do I have it open or no? Do I have to create this or no? Probably create it. Okay. So let's touch dna.py. Okay, so what I'll go ahead and do in dna.py is I'm going to from CS50 import get string. Is that right one? What do I have to do here? Let me check. How to use this program? Okay, I'll read the command line arguments. Okay, so I need to use sys library here. So command line arguments, command line, come on. Okay, from sys import argv. Okay, so I do that. Okay, so I take the input from this one, and then I do some validations, I would believe, right? Your program is executed in the correct number of arguments, you print an error message. Okay, so it should be exactly, the arg count should be exactly 3 in length, I think. Let me quickly check. So if argv, length of argv, it's an array, is not equal to 3 or 3, then I print, what do I print? I print that some error occurred, right? It's kind of, let me assume, okay. You should print error if your choice, okay. Let me print, I don't know, error occurred or something. And then exit 1, maybe? I think that's how you do it. Let me quickly check here. So Python dna.py, if I just do that, error occurred. Okay, cool. But if I supply the right amount of arguments here with Python dna and this guy right here, will it actually execute it? Let's check. Oops, let me copy paste that guy. Okay, so it works. Okay, cool. So that part is down. And yeah, so after that, what we have to do is we have to actually read the CSV file and just open that. Okay, so let's open this and read this. And we have to get the strands, and we also have to read in the individuals here. Okay, so what we're going to do is how do we read the file from what do you call it? How do you read the file? It is open, right? Open CSV. Okay, yeah. Okay, so what we're going to do is we're just do open. Okay, so CSV file equals open, and we take in argv at 1. Sorry, argv at argv at 0, 1, 2, and then open that for reading purposes, right? And then for row in CSV file, print row. Let's just print it for now. Okay, so if I just do that, we don't want to do that. Let me do, we read it, let me do smaller one. What am I doing wrong here? Oh, I'm reading the sequences. Okay, I actually want to read the database. Wait. Which one do I want to read? Do I want to read the sequences, or do I want to read the database? I would assume that I want to read the database small. Okay, so it's one before that, I would assume then. So let me close this. It would be arg at 1, I think, in that case. Okay, perfect. So I'm reading through the line, and I strip each individual line. So I do row.strip. Okay, so what I can do in addition is I say index. I also want the index. So if it's the first row, I want to capture that in some, I want to create a dictionary with the strands. Okay, so what I do is I want Alice to have 283, and I want to actually capture the rows somewhere, right? So I want to have strands in some array. So what I can do is, let me think about the best way I can do this. I'll create a dictionary of these 3 individuals here. So what I'm going to do here is, if index equals 0, that means the first row. Notice I'm using enumerate here, which is a Pythonic thing to do. And if it's the first thing, I create a strands array. And what I need to do is I need to get all the strands. So I say strand for strand in row.split by comma, right? And dot strip, dot strip to remove the new lines. Else I need to have persons dictionary in which I say, let me see here. So I need to have Alice and maybe create a tuple, I guess, since everything is frozen in time, or a list, I guess. I'll just create a list, I guess. So what I'm going to do is I'm going to say, let me think about the best way to do this. Okay, so I'm going to do row dot split by this guy and strip, and it's going to be my current row, and persons at current row at 0 will give me the name is equal to the current row from index 1 onwards using slice operator. So now what I'm going to do is I'm going to print strand, and I'm going to print persons. So let's see what actually happens for this one. List object has no attribute called strip. Okay. Oh yeah, I want to do strip here, and I also want to call strip here before I split. So now let's go ahead and do that. Oh, do I have 2 dots somewhere? Okay. What? I thought I removed it. Line 16. Oh, okay, yeah, okay. Okay, so we have name, and then we don't want to take out the name. We only want the strand. So we do from index 1 onwards. 1 onwards. Okay, so now strands should be, okay, strands is all the strands here, and these are the people. Okay, now what we want to do is we want to, let's make them integers actually, for int of x, for x in this thing. Okay, so now we have all our people, all the strands, and notice I'm using list comprehension. So we have all our strands here and all the Alice with corresponding DNA counts. Okay, now all we want to do is we want to open the text for reading purposes. So for DNA strand in, or actually let's just say DNA strand equals open of arg at 2, open for reading, dots, actually we just do that, and then we'll do for DNA string in DNA, actually we just read it, right? All we want to do is just do read, so we'll just do dot read. So now we're just gonna go through DNA strand using consecutive every consecutive slice, right? So I'll start from 0, and what I'll do is this. So I'll start from 0. While I is less than the length of the DNA strand, I want to iterate, okay? I want to go through in slices, okay? Go through in slices, okay? So what do we have to do here? So here's where it sort of gets tricky, okay? So let me go back. Where was the DNA? Okay. Okay, so what I do is I start from the current index, right? And I take slices, okay? So I take slice from the current index to the length of my strand. So in this example, I would start from I would start from C, and I take, since I'm looking at AGAT, so I need to take substring of 4 in length. So CTAG, so I take that first. It's not equal to strand, right? So in next case, I move the window over. So next iteration will be TAGA. Is that equal to AGAT? No. So I move the window over. So it's sort of a moving window approach, okay? Then I'm at A. This is my third index, right? Or rather index equals 2. So I slice it, and I take my current window here, which is AGAT. So it is equal to AGAT. So I see how much windows, my current windows I can capture, okay? So let me go ahead and incorporate that approach here. So what I'll do is I'll get my current window I'm looking at from DNA strand, DNA strand slice from current index to the length of the strand that I'm examining, okay? And I have to iterate over all the strands here. So let me go ahead and say for strand in strands, iterate over all the strands here, and take the current window. If my current window is equal to the strand I'm examining, then I capture the max result in some variable, or I increment I plus 1. Okay, so let me go back here and show you in the diagram what I mean by that. I start at C, and I take, in this case, say the strand is AGAT. I take window of size 4. Okay, CTAG is my window. It's not equal to AGAT, so I advance the pointer forward. So next I look at T. TAGA, it's not equal to AGAT, so I move the window forward. So now I'm at A. I look at AGAT. AGAT is equal to AGAT, so I see how much I can capture, right? So this is one group. Then I need to move the index over to 5 here, 4 spaces here after that. So and then from here I need to move 4 spaces, from here to 4 spaces, right? This is my approach. It's like a sliding window approach, okay? So here I'll do I plus equals the length of my current window. Length of my strand, sorry, yes. Length of my strand, okay? So here I need to just do max, right? So I need to have some sort of max strands equals -1. I'll be right back. I'm interrupted. I'll probably pick this off in a later video. Okay, we're back. So basically what we're gonna do is the moving window approach. So max strand, it'll be equal to -1. So what I'll do is I'll say max strand equals the max of whatever max I've seen so far, and whatever is however the new max I can go, right? So what I'll do, something like let me say current max, okay? Current max equals 0, okay? And I'll let me see if it's equal to strand. So I'll increment current max and I'll update my max strand, else I'll set the current max to 0. So what I'm doing here is I'm moving the window over. This is a sliding window sort of approach. If I say I encounter the first AGAT, I increment the count and I move my window over, and now my current max is now 1. And here current max will become 2. I move the window over to A. Current max, I increment current max, so it's current max is now 3. I move over the pointer. Now current max is 4. I move the pointer over to G. Now I have to reset my current max. So now it's a G. I look at GACT. It's not equal to my it's not equal to the strand. So I reset my current max. Okay, while I'm going along, I can encounter multiple consecutive ones. So I just take the max strand. I just take the global max strand of everything. Okay, this is how I do it. And then once I do that, once I capture that, in the very end, I have to append it, right? So I have to find. Let me check. So what I have to do is I have to let's see, repeated 4 states, repeated. Okay, yeah. So I increment all the max strands to say a list. Okay, so that's what I'm going to do here. So I am going to say, let me create a global, not global, but create a final strands array here, which is like so, and final strands dot append, and I'm going to append my max strand here that I saw. Okay, and I do that for every single strand. Okay, so let's go ahead and print this. Okay, so print final strands. Okay, what do we want to do here? Okay, so I think that should be it. You may assume that str counts will not match any more than any individuals. If the str counts do not match, okay, no match. Okay, cool. So Python this. Okay, so let's go ahead and try with this piece of text. Actually, is there a smaller piece of text we can try it on? Let's check. Yeah, this is large. I want a smaller piece of text here. Okay, so let's check this with this first. Let's check. Okay, let me so this is my strand array, and this is my list of objects here. So first I just computed the max strands. So let's go ahead and do this. So now my strands is empty. So let's see where we made a mistake here. So current window is I is less than DNA strand. Final strands dot append max strand. Why is that the case? Did I do something wrong? Let me check. Max strand. Max strand. So what I will do here is, let me check where the error is. So let me print strand here. Print strand that I'm examining here. And I print this. Okay, it's not even entering there. Why? What about if I print DNA strand? Is it able to print that? Let's check. Okay, it's able to print that. And then it, for strand and strands. Oh, yeah, okay. I see the mistake here. So this should be strands, okay? So it's a typo here. I put strand equals this thing. Okay, so it should be strands here. And then I run through here and let me comment this out and see if it still works. Go clear. -1, -1, -1. Okay, that's wrong. So let's see where we made a mistake here. Max strand equals max of max strand and current max. Let me see here. So current window. Oh yeah, this should be +1 maybe. So let me check current window. So current window should actually be, oh, nothing's there. Wait. TTAG. Okay, we're making a mistake here somewhere. So let me quickly check here. From I to length of strand +1. What do we want to do here? So DNA strand, we slice it and let me print the current window again. Sorry, it's for some reason it's empty and I can't quite figure out why. Let me check. So if I do that, my current strand is this, current window is this. This current window is equal to strand. Increment my current max and I move the pointer over, so that part is fine. Let me print like current window and let me also print my current strand like so. Okay, now let's see what happens. Okay, current window is empty. Okay, why is that? Am I reading the DNA strand from I to the length of strand? Current strand, okay. Give me a minute here, guys. Let me try to see what the issue is. Okay, welcome guys. I think I found the bug. It was kind of stupid. So DNA strand should be this I plus the length of strand. So it's from the 0 to say like 0 plus the length of strand. If it's at 1, it should be 1 from 1 plus length of strand. So let's try it now and see if it prints the current window. Okay, that's a lot better. That looks a lot better. 415, that's spot. Okay, perfect. So this works. Okay, so that was a silly mistake there. It should be, instead of I to length, it should be I of I plus length. Okay, so I'm just using a window and I'm just going through my strands, this thing, and I'm doing that. So at the end of this, I am going to have something like this. Something like this, and as you can see, strands is 415. I have to just iterate through my person's object here, and if it matches, it will list matches. Then I print the name of the person. Okay, so how can I iterate through dictionary? I can iterate 2 ways. One is name, data in persons dot key dot items. I think that's how I do it. So if data is equal to the final strand strands, I guess, then I print the name of the person. In this case, it'd be Bob, right? So yeah, so if that's not the case, if it didn't enter here, right? If it did not enter here, then I have this weird else here, which prints no match. No match. Is that how I do it? Yeah, it's lowercase m, I guess. So that's pretty much it. So let's comment all this out, and that's pretty much it. These are just the lines of code that which does that. I'm just using a sliding window or the moving window sort of approach. So just to reiterate again, what I do is I start from here, first index. I look at if it's a strand being examined as AGAT, it's window of size 4. So I take the slice of CTAG, right? CTAG is not equal to AGAT, which is a strand being examined. I move the pointer over. So now I'm at T. So now I do from TAGA. TAGA is not equal to AGAT. I move the pointer over to A. Now AGAT is equal to AGAT. So I increment my current max I've seen, which is one strand of 1, consecutive strand of 1. I move the pointer over now, not to G here, but to A here, right? The next 4, the window size over. So I move to next A. I increment my current max, which is 2. I move this. I'm just incrementing the current consecutive count I've seen, and I have this global max here, okay? So if there was others consecutive AGAT here, say there was 2 consecutive AGAT here, the max would still be 4, okay? And then in the next here, when I'm at G, I take GACT. It's not equal to AGAT, so I reset my max, local max, and I still have my global max variable, which updates the count, okay? And that's pretty much it. So let's go ahead and test it right now. And let's actually run this guy right here with this prints Bob no match. Okay, that's wrong. Oh yeah, let's check if let's do this. If it's do that, then it exits with 0, else it prints no match. How about that? That's better, I think. You print and you exit early if there's a match, else you go through it and you print no match. Okay, hopefully that, okay, cool, that works. So now let's check also a few other things, like say lavender. Let's check that. Lavender, okay, that works. And then say Sirius, let's check this. Okay, that works. What about no match? Does that work? Okay, that also works. So let's go ahead and try submitting it, and let's see what we get for the submission, okay? And I'll input here, input 2.txt, and I'll try submitting it. Let's see what we get for when you try to submit it. Okay, let's see what we get in the submission here. And as I told you earlier, basically this is like a window approach. This is how I approached it, but you can approach the problem in multiple ways. Let's try submitting it and see what score we got here. So the idea is that we have this Python script, which is a very short script, and we just use standard submission one, and we got 21 out of 25 with 0.94 as style score. So not too bad, I guess. We passed all the test cases, and style is questionable, but that's okay. So yeah, this was DNA, and I used a lot of list comprehension to make it more Pythonic in nature, and I printed my data structures as I went along. So hopefully that was helpful to you guys. So let me know in the comments if you guys have any questions, or if you would like to make any other, if you have any other approaches in mind, or because I know some other people use regex, regular expressions, for this, and CSV readers. I would like to keep my code simple and just use algorithmic approaches, so I did this. So hopefully this makes some sense. So let me know in the comments if you guys have any questions. Okay, happy coding, stay safe, and enjoy CS50. Bye.